The sun's heat is beneath our feet. Scientists have figured out that Earth's core is actually as hot as the surface of the sun, around 10,800 degrees Fahrenheit. One of the reasons it's so incredibly hot down there is because Earth is still shedding heat from when it was created billions of years ago. Also, when an object as big as Mars slammed into the young Earth, it not only created the moon, according to one theory, but melted the surface of the planet. A lot of that extra heat is probably still stored inside the core. But there's no need to worry. The planet's core is harder for us to access than it is to probe the surface of Pluto. In fact, chances are we may never develop technology that could physically reach the core. There's no air on the moon. But then, how can it be rusting? Scientists have discovered the presence of hematite on the moon, and it's a kind of rust. A special NASA research instrument examined the light reflected off the moon's surface. It turned out that the composition of the satellite's poles was very different from the rest of it. The moon's surface is dotted with iron-rich rocks, but without oxygen and liquid water, rust can't appear. Solar winds add to the mystery. They bombard the moon with hydrogen, and hydrogen makes it much more difficult for hematite to form. Even though the moon doesn't have an atmosphere, it still has some trace amounts of oxygen. Its source is our planet's upper atmosphere. Earth also protects the moon from almost 100% of solar winds, although not all the time. And even though our natural satellite is bone dry, there might be water ice in the shadowed craters on its far side. A day on Uranus lasts 17 hours, 14 minutes, and 24 seconds. But get this, the planet has a tilt of around 98 degrees, and that makes a season on the gas giant last 21 Earth years. Mars has two moons, Phobos and Deimos. In the next 30 to 50 million years, Mars's gravitational forces will tear Phobos apart, and it will likely result in the formation of a ring around the planet. The Earth is the densest in the solar system. At the Earth's center, there's a core that takes up 15% of the planet's volume. It consists of two parts, the outer and the inner core. The inner core is a solid ball made of iron and nickel. Its radius is 760 miles, which makes 20% of the entire Earth's radius and 80% of the Moon's radius. The 1,500-mile thick outer core is liquid. It also consists of iron and nickel, but it's not under enough pressure to be solid. Mars houses the biggest volcano in the solar system. While everything seems to be calm on Mars nowadays, in the past, some sort of force caused enormous volcanoes to form and erupt. One of these volcanoes is Olympus Mons. It's 16 miles tall, which is the height of 3 Mount Everests, and 374 miles across, making it about the size of Arizona. The volcano grew to such a gargantuan size because of the weak gravity on Mars and the lack of tectonic plate movement. Gravity is not the same everywhere. The rocks, metals, and other minerals and substances that make up the planet are packed into the ground more tightly in certain places than in others. This has surprising consequences. Gravity varies slightly depending on where you are. You weigh 0.5% less standing at the equator than you do at the poles. In most cases, that's a difference of less than 1 pound. How high up you are also has an effect. So if you were at the top of Mount Everest, you'd also weigh slightly less. Just don't look down. Earth's toughest living thing is so small you can't see it. Water bears, also known as moss piglets, are cute little creatures with 8 legs and squashed up heads that are less than 1/100th of an inch in length. Despite their microscopic stature, they can basically survive anywhere. They prefer bits of wet moss or the bottom of a lake, but they won't complain if you put them somewhere really uncomfortable. They can endure extreme cold and incredible heat, and survive both huge pressure and high radiation. Some of the little bears once even managed to survive unprotected in outer space for 10 days without a problem. That is tough. They handle all these things by rolling up into a ball and hibernating, which reduces their need for oxygen and food. The moon's gravity is about 17% of that on Earth. If you weighed 200 pounds on our home planet, on the moon, your weight would decrease to a mere 34 pounds. You would also be able to carry stuff 6 times heavier than what you can carry on Earth. It would also be easier to walk on the moon's surface, but it would be more dangerous too. Your feet, inside a heavy spacesuit, would sink into the lunar soil up to 6 inches deep. But let's imagine you decided to skip the tedious process of walking by leaping through the air. Then you'd likely lose control of your jumps in no time. Plus, the moon's surface is littered with deep craters. It would be a tough feat to avoid all of them. You can see solar eclipses because even though the moon is 400 times smaller than the sun, it's also 400 times closer to Earth. So it's perfectly capable of obscuring the star. But in 50 million years, I won't be around then. The moon won't be able to block the sun completely because of the satellite's changing orbit. A full NASA spacesuit costs an unbelievable $12 million. Yeah, I can believe that. 70% of this hefty sum is for the control module and backpack. At the very center of Uranus, there's a rocky core, small, just half the Earth's mass. Compared to other planets, Uranus's core is rather cool, 9,000 degrees Fahrenheit. An ice mantle surrounds the solid core, and that's the largest portion of the planet, about 80%. It's also not the ice you might be thinking about. It's a hot, dense fluid made up of water, ammonia, ice, and methane, sometimes referred to as a water-ammonia ocean. Uranus's atmosphere is mostly hydrogen and helium, but it has its blue-green color because of methane gas that absorbs the red light. The ocean on Jupiter is larger than any other in the solar system. But unlike Earth's oceans, it's made not of water, but of metallic hydrogen. The ocean's depth is a mind-blowing 25,000 miles. That's almost the same as the distance around Earth. Venus is a champ when it comes to volcanoes. The planet has about 1,600 major ones, but none of them is known to erupt. There's a supermassive black hole 250 million light-years away from us. It hums the deepest sound ever detected from any object in the universe. It's 57 octaves lower than the middle C on your piano. That's 1 quadrillion times deeper than what we can hear. Mercury is a few billion years old. In 2016, scientists discovered some abnormalities on the planet's surface, showing that it's getting smaller. After more research, they found out that Mercury hadn't finished cooling down yet. There are planets that aren't bound to any star orbit and aimlessly wander through outer space. Among the most spectacular-looking space objects are pulsars. Pulsars are a type of neutron star. They shoot out some of their material almost at the speed of light. Regular pulsars spin at a reasonable speed, between 1/10 to 60 times per second. But millisecond pulsars can spin at an impressive 700 times a second, which is way too fast for the human eye to even process. As they spin, they emit a beam of radiation from their axis that looks like the light from a lighthouse. Astronomers can notice pulsars when they face Earth, since it looks like a light being shined on our planet. When the light shines elsewhere, the pulsar can't be seen. Our sun is insanely massive. Want some proof? 99.86% of all the mass in the solar system is the mass of the sun. In particular, the hydrogen and helium it's made of. The remaining 0.14% is mostly the mass of the solar system's 8 planets. Saturn's rings are very thin compared to its size. If you had a scale model of the planet that was 3 feet wide, the rings would be 10,000 times thinner than a razor blade. Even though Venus is the hottest planet in our solar system, it still has snow. But not what you'd expect. It snows metals and rains acid. Not a great vacation spot.
As you know, all the planets in our solar system orbit the Sun and bring a sense of order to the place. But guess what? There are two planets that could collide with each other and cause a cosmic catastrophe. Here's Neptune, the most faraway planet in our solar system. It's 17 times heavier and 4 times bigger than the Earth. It's 30 astronomical units from the Sun. 1 AU is the distance between the Sun and the Earth, so it's 30 times farther away from our star than we are. And Neptune makes a complete circle around the Sun in 164 years in an almost perfectly round orbit. Neptune is cold, calm, and stable. But there's one planet that can ruin this balance: Pluto. It's a dwarf planet covered in rocks and ice. It's 6 times lighter and 3 times smaller than the Moon. We're interested in its orbit. If you look at a map of the solar system from above, you can see that it's not round but elliptical, so it's a slightly flattened circle. At its furthest point, Pluto is 49 Earth-Sun distances away from the Sun. When it moves, it comes closer to the star. At its closest point, Pluto is about 29.5 AU from the Sun. That's closer than Neptune. So, hypothetically, they could collide. Let's look at this collision from the front row. A little closer, please. Good. Neptune and Pluto are slowly approaching each other. They are both very cold worlds, but they begin to interact with each other gravitationally. Just like two magnets, it warms them up from the inside. Neptune is a gas giant. There's no solid surface there, so there's not much change in it yet. But Pluto has a rocky surface. Because of Neptune's gravitational influence, it's starting to crack. Pluto experiences continuous earthquakes. This causes it to heat up even more. When Pluto almost touches the gas giant, it begins to crumble from the inside out. Plus, Neptune has a very dense atmosphere, so the dwarf planet begins to ignite from friction with the gases in the upper atmosphere. Pluto is now very hot on one side and very cold on the other. This causes severe deformation, and it begins to crumble. Half of the dwarf planet's fragments remain in Neptune's orbit. They will collide with each other until they turn into dust and become new rings of the big planet. Other fragments will burn up in Neptune's atmosphere, and the biggest rocks that remain of Pluto will fall through Neptune until they're completely burned into dust. Neptune literally ate Pluto and continued its orbit without any change, all because the gas giant is 20 times larger and much heavier than the dwarf planet. So this collision would do no harm to Pluto. But it couldn't have happened in the first place, because their orbits don't actually cross. Let's look at the map of the solar system again, not from above, but from the side. All 9 planets here are on a horizontal line from the Sun. The distance between them is great, and their orbits don't cross. Here's Pluto's orbit. You can see that it's tilted relative to the horizontal line of all the other planets. It starts at the top, then dives under the orbits of the planets and comes back. So Pluto can never collide with Neptune. Still, planetary collisions have occurred in our solar system before, and thanks to these collisions, life appeared on Earth. Let's go back in time to almost 4.5 billion years ago. This ball of hot lava is Earth. It just formed from a cloud of dust and began to cool. But then, a wandering planet the size of Mars appeared on the horizon. It's called Theia. It was inevitably approaching our planet. The collision with Theia happened at a perfect angle. If Theia had hit us head-on, both planets would have been smashed to pieces. But it hit us almost at a tangent. Theia knocked some of the matter out of the young Earth and crumbled into rubble itself. It could no longer continue its journey because the Earth caught it in a gravitational trap. A large fragment of this planet remained in our orbit. Smaller fragments crashed into each other, falling to Earth or joining the remains of Theia. The dust settled, and we can see the familiar picture: the Earth and the Moon. This is the main theory of how it came to be next to us. Scientists say that it was this collision that caused life to appear on Earth. Theia brought a lot of ice on it, which turned into water on our planet. The new moon stabilized Earth's rotation, and conditions on the planet became perfect for the emergence of life. Another collision could create a blast wave that would spread out thousands of light years. Stellar collision. This usually occurs in binary systems with a white dwarf and a regular star like our Sun. A white dwarf is the remains of a star that has gone out. As the stars get together, they start to move around each other in a spiral-like dance. The white dwarf pulls down the upper layers of the larger star. This hot plasma and stardust form a luminous disk. The two stars get closer and closer. When they finally merge, this causes a chain reaction in the core of the hot star. The massive matter presses on the star's core too hard. This causes the innards of the combined star to heat up even more, and it expands, creating a supernova. This is one of the brightest events in the universe. The light from the explosion can be seen hundreds of light years away. Another spectacular view is the collision of a star with a black hole. Black holes are the heaviest objects in the universe, and their gravity is incredibly strong. So, when a star and a black hole get close, the black hole starts eating the lighter matter of the star. The hot plasma, like spaghetti, heads toward the heart of the black nothingness. For an observer, this plasma seems to settle on the very edge of the black hole. It's called the event horizon. The thing is that time is much slower near such a heavy object. So we think the matter stays on the event horizon, but in fact it's long gone into the heart of the black hole. As they get even closer, the black hole starts to literally tear the star apart and swallows it whole. At this point, the black hole spits out about half of the star's mass in the form of a beam of energy right out of its black heart. The other half of the star's mass becomes the black beast's food. We know of many black holes in our universe. The heaviest of them usually lies in the centers of galaxies. They can be millions of times heavier than the Sun. But what would happen if two black holes collided with each other? Our scientists had the opportunity to observe such an event. Two black holes weighing 66 and 85 solar masses gradually approached each other. They danced together, bending the light passing by them. But then they merged into one enormous black hole, weighing 142 solar masses. That same second, the new black hole released gravitational waves into space with an energy of 9 solar masses. Scientists were able to catch these waves and observe the merging of the two black holes from the front seat. But this event actually happened about 17 billion years ago. We're only now seeing it because the particles of light and gravitational waves took so long to travel the distance of 17 billion light-years to Earth. Now consider a galactic scale collision. Literally, it's a collision of the Milky Way and the Andromeda galaxy. This event will happen in 4.5 billion years, so stay tuned. The Milky Way has almost 100 billion stars. Andromeda has about 1 trillion. As the galaxies approach one another, they'll make several circles around each other. At that time, some stars may be ejected from the galaxies like from a slingshot. Then Milky Way and Andromeda will begin to merge. One scenario here is that our solar system will collide with another star system from Andromeda. In this case, there could be a stellar collision and a supernova afterwards. Our world would be destroyed. Another option is that the Sun would be ejected into dark space. In this case, we may not even notice the difference. All we'll see on Earth is a gradually disappearing starry sky, as our solar system will travel through dark space away from the home galaxy. But the most likely scenario is when the galaxies merge, it'll be completely painless for us. In fact, the space is very wide, and there's room for all the stars from both galaxies. The only difference is that we'll see a lot of new stars in the night sky, along with flying saucers from Andromeda. Nah, not really. But it's not the collision of galaxies that we should be worried about. It's our Sun. In 4.5 billion years, it'll become a red giant. It'll expand, swallowing up the nearest planets. Earth will probably be the first planet near the Sun. It'll be so hot that all life will simply disappear, and no one will be able to watch the galactic collision.
Venus has exceptionally high temperatures, hot enough to melt lead. It's the hottest planet in our solar system, with a high-pressure environment and super strong winds. The winds there are 50 times faster than the planet's rotation. It's getting stronger over time, and scientists don't know why. But they did find something interesting in the planet's clouds, a potential sign of decaying biological matter. Could there be life then? Not quite, since Venus has a dry, windy atmosphere and doesn't have enough water for life to develop. Rings around other planets are more common than we thought. Saturn's rings are the most famous and spectacular ones. They partially consist of reflective, sparkly water ice, and you can't see anything like that in the rest of our solar system. Jupiter, Uranus and Neptune have ring systems too, and those most likely consist of dust and rocky particles. And not just planets. Astronomers found out rings were around one asteroid as well. Speaking of rings, why do you think that Earth doesn't have them? Gas giants have rings, while the rocky ones don't. Two theories explain how rings form. They could be the remains from the times when planets were forming, or they could be leftover material of an impact that destroyed an unknown moon, or gravity broke apart this moon of its parent planet. It's not clear why only the gas planets have rings. They formed in the outer area of our solar system, while rocky planets only in its inner circles. May be a good clue. Maybe these inner rocky planets had just better protection from strong impacts that could have formed rings. Also, there are more moons in the outer solar system, and there are more rings there. Another thing may be that bigger planets have a bigger volume, so a ring system can remain stable there. Some theories even say that Earth used to have a ring system. A long time ago, our planet collided with a Mars-sized object, which most likely resulted in a dense ring of particles and debris. But our story was a bit different than the outer planets, and those rings probably combined and formed the Moon. Do we know the shape of the universe? Einstein had a theory of general relativity. It said that the universe could be in one of these three forms: closed like a sphere, open like a saddle, or flat like a piece of paper. Its shape determines whether it's infinite or not, and whether it will expand forever or maybe collapse at some point. The shape of the universe depends on its density and rate of expansion. One of the best ways to determine its shape is to use something called the cosmic microwave background. It's the relic afterglow, something that's left of the Big Bang. Sound waves that were moving through the universe in its early stages produced quite small spatial variations in the temperature of its faint light. The result of these studies showed that the universe probably expands in all directions, which means it's flat. How come our sun is hot while the moon is cold? The sun gives off heat because its core is extremely hot. In there, the pressure is pretty high. The hydrogen turns into helium. That's how the sun creates light and heat. The solar light and heat are enough to light up our days on Earth, as well as support life here, even though the sun is around 93 million miles away from us. The moon is not hot because it doesn't have an atmosphere, so it can't absorb sunlight as our planet does. Its surface gets very hot in the daytime, about 210 degrees Fahrenheit, but since there's no atmosphere, the temperature drops extremely during the night to negative 279 degrees Fahrenheit. The sun is hot, no doubt there, but the space around it is very cold. Heat is the energy objects store inside of it. Temperature is how we measure if something is hot or cold. So when you transfer heat to certain objects, its temperature goes up. Take it away, and the temperature goes down. You can transfer heat in three different ways: convection, conduction, and radiation. Convection works within gases and liquids, and conduction is for solids. The temperature only affects matter. Space doesn't have enough particles. It's nearly a complete vacuum, which means transferring heat is not effective. The only way to do it is through radiation. When the heat coming from the sun falls on an object in the form of radiation, the atoms that make up that object will absorb energy. This energy moves the atoms and makes them produce heat throughout this process. In space, temperatures of the objects stay the same for a long time. Cold objects stay cold, and hot ones stay hot. If you place anything outside of the Earth's atmosphere and expose it to direct sunlight, the sun will heat it to about 250 degrees Fahrenheit. Objects in outer space that surround our planet and don't receive sunlight directly are at 50 degrees Fahrenheit. The temperature is like this because there are molecules that escape our atmosphere, so the sun heats them. We used to think that water was really rare in space, but now we know there's water ice across our entire solar system. For starters, you can usually find water on asteroids and comets. It's also in craters on Mercury and the Moon. that are in permanent shadows. On Mars, you'd find ice at its poles, under the surface dust and in frost. It might not be enough to support human colonies up there, but it's still something. Some other bodies in our solar system also contain ice, like the dwarf planet Ceres and one of Saturn's moons. Europa, one of Jupiter's moons, could be one of the most likely candidates we know about that could contain life. It probably has an entire ocean under its frozen and cracked surface. It could have twice as much water as all oceans on our planet together. Titan, the biggest of Saturn's moons, also has a liquid cycle, but it's not water. Its cycle moves materials between the surface and the atmosphere. At first, it sounds like the water cycle we have on Earth. But immense lakes on Titan are filled with ethane and methane. There's a chance they're over a layer of water. Neptune is about 30 times as far from the Sun as we are. Of course, it gets significantly less light and heat than Earth, but it also radiates way more heat than it's generating. There are more things happening in its atmosphere, especially if you compare it to its neighbor, Uranus. Uranus is closer to the Sun, but it still radiates the same amount of heat as Neptune. The winds on Neptune are insanely strong, 1,500 miles per hour. No one still knows why. It could be a gravitational contraction, energy coming from its core, or the Sun. I hope we'll eventually find out. Can you imagine hot ice? It exists just 33 light-years away from us, on one exoplanet. This planet consists of different water elements and they form burning ice. The ice there is solid because of pressure, but the surface temperatures are extreme and go up to 570 degrees Fahrenheit. That's how the water stays super hot and comes off as steam. Picture putting ice in your coffee when you want to heat it up. When you stargaze, it's almost like you're looking into the past. Stars are really far away, and it takes longer for their light to reach our planet. So it's possible some of them have already run out of fuel and aren't alive anymore. The Pillars of Creation are a good example. This is part of a region 7,000 light-years away from us called the Eagle Nebula. These are clouds of gas and dust in the shape of pillars. Scientists first discovered it in 1995, but in reality, a supernova explosion destroyed these pillars that were at least 6,000 years ago. So, the 1995 image shows these pillars from 7,000 years ago. Mars has the biggest volcano in the solar system that we know of so far. It's bigger than the whole state of Hawaii, and 100 times larger than the biggest volcano on Earth. The red planet seems so quiet, but once upon a time, large volcanoes dominated its surface. Volcanoes on the red planet can probably grow so big because gravity there is a lot weaker than down on Earth. Also, the crust on our planet is moving all the time, and the Martian crust probably stays still.